I'm Anil Kumar. Most of the trigonometric identities which we have solved so far, we have started from one side and proven that to be equal to the other side. But here are a few examples where I prefer to solve both the sides. So this particular example is the one where it is better to solve from both the sides. So let's say this is the right side. So on the right side we can take cos x common. So we'll start with the right side. We have cos x common, and numerator could be written as cos x plus 1. Denominator is minus sine square x, so it is minus sine square x could be written as 1 minus cos square x. Okay. Now we can write 1 minus cos square x as product of sum and difference, right? So we get cos x times cos x plus 1 in the numerator, and the denominator is 1 minus cos x with a negative sign times 1 plus cos x, right? Now 1 plus cos x and 1 plus cos x cancels out, so you have cos x divided by, you could write this as minus 1 minus cos x, or let's keep it 1 minus cos x for the time being. So that is the simplification of the right side. Now let's look into the left side and see how to simplify the left side. Now in the left side we have minus 1, and here we have sine square x. So we could write sine square x minus 1 as minus cos square x, correct? So let me show you how. We have sine square x plus cos square x equals to 1. Now if I bring 1 on this side, then it becomes sine square x minus 1 equals to minus cos square x. So using these two terms, we will write this as minus cos square x. So sine square x minus 1, or we could write like this, minus of 1 minus sine square x to start with, that is better, plus 2 cos x in the numerator, right? So that becomes the numerator for us, and the denominator, which we have sine square x, we could always write this as 1 minus cos square x, right? And we have plus 3 cos x minus 3. Now that gives us minus cos square x plus 2 cos x, right? So plus 2 cos x divided by, now here we can combine the terms. We'll take minus outside, so we'll try to factor this term. So we have cos square x minus 3 cos x, but since I took minus here, minus 3 cos x, and 1 minus 3 is minus 2, but we'll do plus 2 here. When you open, you get minus 2, correct? So that is how you could do this. And now we can factor both numerator and denominator. Numerator, you get minus cos x here, so you get cos x minus 2 in the numerator. In the denominator, we need product of 2, sum of minus 3, so it could be written as cos x minus 2 times cos x minus 1, correct? Now cos x minus 2, cos x minus 2 cancel out, minus minus cancels out, and what you get here is cos x over cos x minus 1, and that is same as this. So this is also cos x. When you open the bracket, this becomes positive, so you get cos x minus 1. So what we see is left side is equals to right side. So this particular example is the one which you should solve both sides and come to the same answer. So that is how you prove this. So in this particular example, I hope you appreciate, it becomes much simpler if you solve both the sides. I hope that helps. Thank you.